Hey guys, today we're going to practice pretty much everything that we've covered on derivatives so far. So for example, here we have the graph of f of x. Now remember that this is your function. So the questions are going to be related to the derivative, and we have to be able to state what the derivative is doing or the type of values that the derivative has based on the function. So in this first question, on what interval will f prime of x be greater than 0? Now sometimes it's easier to think of the justification for it first, so that way you know what to look for on the graph. I know that f prime of x is greater than 0 when my function would be increasing. So if I look here, my function starts to increase at this point in time, and then it's going up until this point. Now this is x is equal to, and it's approximately negative 1.25. Since this is negative 1 and it's right in the middle between negative 1 and negative 1.5, I'm going to say that it's about negative 1.25. Then it increases up until this point. This is 1 and it's right in the line after, so we'll say this is 1.5. Then it starts to increase again about right here. And same thing, this is x is equal to about 4.25, and then it is increasing the rest of the time. So therefore, the function is increasing, which means that the derivative is greater than 0, from negative 1.25 to 1.5, u 4.25 to infinity, because f of x is increasing. Now, on what interval will f prime of x be less than 0? So that means that my function will be decreasing. And if I look at my graph, I'm just going to switch colors here, we can see that it starts to decrease from the very beginning, so from negative infinity, and then it decreases again in this area of the graph. Therefore, f prime of x will be less than 0 from negative infinity until negative 1.25 union 1.5 to 4.25. And this would be because f of x is decreasing. Now, use the graph of f of x to estimate the value of f prime of 3. When we are estimating a derivative value, this means that we are going to find the slope of the secant line, simply because we don't have the actual derivative equation, or rather the function equation, for me to take the derivative. So estimating, we would use the slope of the secant line, since the secant line runs almost parallel, if not exactly parallel, to your tangent line. So we would state that f prime of 3 is approximately. Now I'm going to choose 2 points, one on either side of 3. So here's 3, so I'm going to choose f of 2 and f of 4, just over here. So the slope would be f of 2 minus f of 4 over 2 minus 4. Now f of 2 is equal to 4 minus f of 4, which is negative 4, so I'm going to put plus 4, over 2 minus 4, which is negative 2. 4 plus 4 is 8, and 8 divided by negative 2 is negative 4. And you always want to double check, does my slope make sense with the graph behavior? Since my slope is negative, that means that my graph is decreasing when x is equal to 3, which it is. So we're good to go. So this would be my f prime of 3. Now for this part, where we're writing the equation of the tangent line at x is equal to 3, I have the slope. What I need is the point. So f of 3, we need the actual y value in order to get my point of tangency. And f of 3 is equal to 0. So now I'm ready to write my equation. Y minus y1, which is 0, is equal to m, so negative 4, times x minus x1, which is 3. So this is my equation of the tangent line when x is equal to 3. Now we're going to estimate the derivative values based on a chart. Okay, so when we're working with derivatives or we're working with anything in calculus, you're going to see various representations. You're going to see graphs like we just did, charts, and equations as well. So we have to know how to go between each type of representation and find the derivative no matter what's given to us. So for all of these, we're just going to estimate the derivative from the chart for these particular x values. Then we're going to state if the function is increasing or decreasing, and then we're going to write the equation of the tangent line at that value of x. So again, my chart here, I have x's in the first row and f of x, which is your y values, on the second row. So if I want to estimate f of 0, I would have to pick the 2 points on either side. Now, when you look at the chart, we're only using chart values. So I would have to choose -3 and 1 in order to estimate f prime of 0. So we would write f of -3 minus f of 1 over -3 minus 1. F of -3 is equal to 2, and minus f of 1, which is -3, so plus 3, over -4, which gives me a -5 over 4. Since my slope is negative, that means that the function is decreasing. Now to write the equation of the tangent line when x is equal to 0, we need the y value, which is on the chart. So we would write y minus the y value, which is 1, is equal to -5 over 4, parentheses, x minus 0. Now you could have also just have written y minus 1 is equal to -5 over 4x. Or you could have also written y equals -5 over 4x plus 1 if you decided to add the 1 to the other side. Either way, it would have been fine. Now we're going to do this again, but for f of 1. So I'm just going to switch colors here so that way it's easier to see. So we have f prime of 1 is approximately, now we're looking at 1. So that's my x value, that's my y value for when I write my equation of the tangent line, and I have to choose the 2 points on either side of 1. So I would state that f prime of 1 is approximately f of 0 minus f of 4 over 0 minus 4. Now f of 0 is 1 minus 0 over 0 minus 4, which gives me a -1 over 4. Again, we have a negative slope, so that must mean that my function is decreasing at that point. And you can see this, right? If we go to x is equal to 1, if you look on the left and to the right, we see that we go from 1 to -3, meaning that it is decreasing. So now to write the equation, we would state y minus the y1, which is -3, so plus 3, is equal to -1 over 4, parentheses, x minus 1. Now for our last one, we're going to estimate f prime of 6. So here we go. F prime of 6 is approximately, so now we're going to use f of 4 and f of 10. So f of 4 minus f of 10 over 4 minus 10. F of 4 is equal to 0 minus f of 10, which is 2, over 4 minus 10, which is -6. So -2 divided by -6 is a positive 1 over 3. So since my slope is positive, that means that my function is increasing. And now to write the equation, for f of 6, my y value is -7. So my equation would be y minus -7, so plus 7, is equal to 1 over 3, parentheses, x minus 6. Now we're going to have a look at another problem using charts. But this time, the chart is h prime of x. So we're looking at the derivative. Now, as it's stated in this verbal description here, it says a table of values below represents values on the graph of the derivative h prime. The zeros indicated in the table are the only zeros on the graph of h prime of x. Use the table to answer the following questions, and of course we're going to justify those answers. Now, our critical numbers. The critical numbers of the derivative is when f prime of x, or in this case h prime of x, is equal to 0. Therefore, we're going to look here at the bottom row. These are all of the y values for the derivative, and it equals to 0 here and here. So my critical numbers are x is equal to -2 and 7 because h prime of x is equal to 0. Now we're going to look at on what intervals is h of x increasing and decreasing. So first of all, I would see that the function is increasing when the derivative is positive. So remember, when we're writing our intervals, we're always using just the critical numbers. So when I look here, I can see that my function is increasing when the derivative is positive. So that would be from -8. We don't like to assume that our charts extend past the values unless it's told to us. So my function would be increasing from -8 until -2 because that is my critical number. Then these are all negative and these are all negative. So just -8 to -2, and we would say because h prime of x is greater than 0. Then the function is decreasing when the derivative is negative, which again, we use only the critical numbers, and this occurs from -2 to 7 because everything here in between is all negative, and then from 7 to 12 because these are all negative as well. So for decreasing, we would state from -2 to 7, 7 to 12 because h prime of x is less than 0. Now, at what values of x does the graph of h of x have a relative maximum? So remember that our maximums and minimums only occur at critical numbers. These are my two critical numbers, as I've already stated. And we would have a maximum when the derivative changes from positive to negative. So we would look at either side of each critical number. This one here is positive, and then it's negative. So this would be a maximum. So we have h of x has a relative maximum at x is equal to -2, and we would state because h prime of x changes from positive to negative. Then finally, at what values of x does the graph of h of x have a relative minimum? The only other critical number is 7. Now to the left of 7 is a negative value, but to the right of 7 it's also a negative value, so it did not change. Therefore, h of x does not have a minimum because h prime of x does not change from negative to positive. Even if you do not have any minimum or maximum, or it's never increasing or decreasing, you still have to state the reason why that does not exist. For E, if h of 3 is equal to 2, what is the equation of the tangent line to the graph of h of x at x is equal to 3? So we have our point of tangency that was given to us in this question. That is the h of 3 is equal to 2. So that means we have the coordinate 3, 2. What I'm missing is the slope. So that is h prime of 3. Now since this is the chart for h prime, that means that h prime of 3 is equal to -3. So that is my slope. So my equation would be y minus 2 equals -3, x minus 3. And then we're going to find the tangent line approximation of h of 3.1. Now, what does this mean? When we're finding a tangent line approximation, that means that we're trying to approximate for the actual function value of h of 3.1. Now, this is the derivative chart. We don't know anything about the function. We don't know what this value would be. But since the tangent line we found was for when x is equal to 3, that's very, very close to 3.1. So if I plug in 3.1 into my tangent line equation, then it's going to give me a value that is very, very close to the actual function value. So all I have to do is take that 3.1 and plug it into my equation. So y minus 2 is equal to negative 3 times 3.1 minus 3. And this we can do without a calculator. So y minus 2 is equal to negative 3. 3.1 minus 3 is 0.1. Then negative 3 times 0.1 is negative 0.3. And finally, I would add the 2. So y is equal to 1.7. Now this is not how I want to write my final answer. We are approximating h of 3.1. So make sure that you always answer the question in the correct format. So this is h of 3.1 is approximately 1.7. Now I had mentioned normal lines before in class, so we're just going to look a little closer at what the normal line is. So first we're just going to answer these questions and then we'll get into that. So here we have the graph of f of x, and first we're going to estimate the value of f prime of 1. And again, I do this because I don't have the actual function equation, so I can't just find the derivative. So here is x is equal to 1, and remember that you're going to use a point to the left and to the right of 1. So we're going to use f prime of 1 is approximately f of 0 minus f of 2 over 0 minus 2. Now f of 0 is right in the middle between 3 and 4, so 3.5, minus f of 2, which is also right in the middle between 0 and negative 1, so a negative 0.5, making this a positive 0.5, over 0 minus 2, which is negative 2. 3.5 plus 0.5 is equal to 4, and 4 divided by negative 2 is negative 2. So f prime of 1 is approximately negative 2. Now to write the equation of the tangent line to the graph of f of x at x is equal to 1, I have my slope, but I'm missing the y value. And since this is the graph of f of x, I can look at x is equal to 1, and I get that f of 1 is equal to 2. This is my point of tangency. So my equation would be y minus 2 is equal to negative 2 x minus 1. So just to give you a visual, when you have your tangent line, it goes very, very close to your graph. The normal line goes perpendicular to that tangent line, and additionally, it goes through the same point of tangency. So when I need to write the equation of the normal line, my equation would be essentially the same, except we would rewrite the slope to represent the perpendicular slope. And the perpendicular slope would be a positive 1/2. So that means that my equation for the normal line would be y minus 2 is equal to 1/2 x minus 1. Now we're going to kind of put this all together and answer some additional questions. Here we have the derivative graph. So this is h prime of x, and we're going to answer a bunch of questions in terms of our actual function. So this first one says the interval where h of x is increasing. So I want to know from this graph where it is increasing. Now keep in mind, remember I always think of my justification first. My function would be increasing when the derivative is greater than 0. That means that I'm going to take a look at my critical numbers, which are when h prime of x is equal to 0. This is, what's it called? This is what separates the positive values and the negative values. So for positive, I'm just going to highlight it here. My positive values are when my function is above the x-axis. So it's all of this. So this is my positive derivative. Then my negative values is when it is below the x-axis. Now this is important because when I'm trying to figure out when my function is increasing and decreasing, it all depends on whether my derivative is positive or negative. So the interval where h of x is increasing would be from negative 2 to 1, u3 to infinity, because h prime of x is greater than 0. Now when my function is decreasing, that's the pink here, and that would be from negative infinity to negative 2, u1 to 3. And this is because h prime of x is less than 0. Now the values of x, where h of x has a relative maximum. So this is when the derivative changes from positive to negative, which only occurs at one spot, which is right here. And this is where x is equal to 1. So the h of x has a relative maximum at x is equal to 1, and this is because h prime of x changes from positive to negative. Then where my function has a relative minimum, that occurs when my derivative changes from negative to positive, which occurs here and here. And this is x is equal to negative 2, and this is x is equal to 3. So we have two relative minimums at x is equal to negative 2 and 3, and we would state because h prime of x changes from negative to positive. Now for this follow-up question. If h of negative 1 is equal to 1/2, what is the equation of the tangent line drawn to the graph of h of x at x is equal to negative 1? So I have my point of tangency, which is given to me in the problem. That's negative 1, 1/2. What I'm missing is h prime of negative 1. Now again, this is the graph of h prime. So I would just have to go to negative 1, and I see that the y value is 2. That is my slope. So now I have everything. So now I'm ready to write my equation. Y minus 1/2 is equal to 2 times x plus 1. And last one here, if h of 2 is equal to negative 3, again, I have my point of tangency. What is the equation of the normal line drawn to the graph of h of x at x is equal to 2? So that means I need first my derivative. So h prime of 2, when I look at my graph, I see that h prime of 2 is equal to negative 1. Now because I'm writing the equation of my normal line, I need the perpendicular slope, which would equal to 1. So now my equation would be y plus 3, since this is my point of tangency, is equal to 1 times x minus 2. Let's just keep on practicing. So here we have the graph of the function, so not the derivative. And additionally, we're given the equation of the function. So if I want to find g prime of 4, that means I'm actually looking for the derivative value. I am not estimating. And so since I have g of x, I'm able to find this derivative. Now this does not look like polynomial form, so I would have to rewrite it in polynomial form, meaning that I'm going to take g of x, and I'm going to distribute that x plus 2 squared, so that's x plus 2 times x plus 2 minus 4. So I have this 1/2. When I FOIL x plus 2 times x plus 2, I would get x squared plus 2x plus another 2x, so plus 4x plus 4 minus 4. Now I'm going to distribute the 1/2, which would equal to 1/2 x squared plus 2x plus 2 minus 4. And finally, just combine those last like terms. So 1/2 x squared plus 2x minus 2. Now I'm ready to find g prime of x. And g prime of x, this is just the power rule. So I would multiply the 1/2 with the 2, which is just x plus 2. But my question was to find g prime of negative 4. So when I plug in negative 4, I would get negative 4 plus 2, which is equal to negative 2. So this is my slope of the tangent line at x is equal to negative 4. For part B, we're writing the equation of the tangent line drawn to the graph of g of x at x is equal to negative 4. So what I'm missing, I have the actual derivative, which is my slope. I'm missing my point of tangency. So that means that I'm looking for g of -4. When I look at my graph, g of -4 is equal to -2. So now I'm ready to write my equation. Y plus 2 is equal to -2, my slope, times x plus 4. Now we're going to find the tangent line approximation at x is equal to -3.9. Since this is the equation for when x is equal to -4, -3.9 is really close to it. So I'm going to plug in -3.9 into my equation. So y plus 2 is equal to -2 times -3.9 plus 4. And I'm going to just work this out. -3.9 plus 4 is 0.1. When I distribute the -2, that will give me -0.2. And then when I subtract the 2, I get y is equal to -2.2. So this is my approximation. So I would write g of -3.9 is approximately -2.2. Now, an additional question when you see these approximations is usually, is this an under or an over approximation? And that all depends on the concavity of your function. The concavity, just basically what that looks like, is how your graph is opening. Is it opening upwards or is it opening downwards? So this function is concave up because it is opening upwards, versus a function that looks like this. This would be concave down. And concavity can change throughout your graph if it has multiple curves. But anyway, so if your function is concave up, that means that my tangent line would lie below the graph, making this an under approximation. Now, if you had a concave down function, let's say I had a tangent line here, we see that the tangent line is above the graph, making anything that is concave down an over approximation. So we would have to pay attention to the concavity. Since this is a concave up function, that means that this is an under approximation. Moving along, we're going to, again, just keep practicing. We have the function g of x, and we have the actual equation along with the graph. So based on the graph, so we're using the graph to answer these questions. At what value does the graph have a horizontal tangent? So I'm going to answer the following question after that, but let's just go ahead and answer this one. We have a horizontal tangent when the function would have a maximum or minimum, which is right here. This looks to be my maximum, and this is x is equal to 1. So g of x would have a horizontal tangent at x is equal to 1, and we would say because g of x has a maximum. Now, for the second part of this question, it says to give a reason, which I already did, and show an algebraic analysis that supports our answer. An algebraic analysis is basically to actually find the derivative based on the equation. So when I look at my equation, this is in polynomial type form, except we have this square root, which when we're trying to find the derivative is very difficult unless we rewrite it using an exponent. So g of x is equal to 2x to the 1/2 minus x plus 2. So now I'm ready to find the derivative. So g prime of x is equal to x to the negative 1/2, because I had to subtract 1 from 1/2, minus 1. And because we want to show when it has a horizontal tangent, we're going to make this equal to 0. Now, it's difficult to solve when we have a negative exponent, so I'm going to rewrite this as a positive exponent and put it back in my root. So x to the negative 1/2 is equivalent to 1 over the square root of x. Since the exponent is 1/2, this is the square root, negative exponent moves down to the denominator. Minus 1 equals 0. So now I'm going to add the 1 to the other side. So 1 over the square root of x is equal to 1. I want to move that square root from the denominator, so I'm going to multiply the square root of x to both sides, which would give me 1 is equal to the square root of x. And then finally, I would square both sides, which gives me the answer that I had stated earlier, x is equal to 1. Now, on what intervals is g prime of x greater than 0? On what interval is g prime of x less than 0? And we're going to give a reason. So here we're just going to use the graph because it's the easier of the two. G prime of x is greater than 0 when my function is increasing, which is in this section right here, because then it decreases the rest of the time. So we would state g prime of x is greater than 0 on the interval 0 to 1 because g of x is increasing. Now we would do the same thing for g prime of x is less than 0. Now when we look at the graph, g prime of x is less than 0 when my function is decreasing. Where it starts decreasing is at 1 and then it decreases the rest of the time, so to infinity. And we would state because g of x is decreasing. Now for our final question here, for what values of x is the slope of the tangent line equal to 2? So remember, slope of the tangent line, you have to think derivative, and it has to equal to 2. So I'm going to take my derivative equation, which I had already found over here. So x to the negative 1/2 minus 1 is equal to 2, and we got to solve. Now remember, we rewrite this as 1 over the square root of x. I'm going to add the 1 over, so it equals to 3. Then we would multiply the square root of x to both sides to cancel it out. So we have 3 square root of x is equal to 1. Divide the 3. We have the square root of x is equal to 1/3. And finally, we square both sides. When you square a fraction, as a reminder, that means to square the numerator and square the denominator. So x would equal to 1 over 9, and that would give me the slope of the tangent line would equal to 0. Now over here we have the equation of the derivative. So we don't really have to find the derivative, it's already given to us. On what interval is f of x increasing and when is it decreasing? What I'm going to need is my critical numbers. When I look at my derivative equation, it's already been factored. So my critical numbers would be x is equal to 0, 2, and negative 3. So what I'm going to do now is I'm going to put f prime of x on a number line with those critical numbers. So negative 3, 0, and 2. And then I'm going to plug in test values in between each of those intervals into my derivative so I can get the sign. So for the left of negative 3, I'm going to choose negative 4. When I plug in negative 4, I get negative, and then 2 plus 4 would be positive, and then negative. So a negative, positive, negative would give me a positive number. If I plug in negative 2, I would get a negative, positive, positive, giving me a negative number. When I plug in 1, I get positive, 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 so positive. And then if I plug in 3, I get positive, negative, positive, giving me negative. So this is everything I need to answer all of these questions. On what interval is f of x increasing? We would state f of x is increasing from negative infinity to negative 3, u 0 to 2, because f prime of x is greater than 0. Now, f of x is decreasing from negative 3 to 0, u 2 to infinity, because f prime of x is less than 0. At what values of x does the graph of f of x reach a relative minimum, and when does it reach a relative maximum? So let's start with the minimum. When I look here at my number line, I have, this is a maximum because it changes from positive to negative. This is a minimum because it changes from negative to positive, and this is a maximum. So we have a minimum at x is equal to 0 because f prime of x changes from negative to positive. Then we would have a maximum at x is equal to negative 3 and 2 because f prime of x changes from positive to negative. For C, we have if f of 4 is equal to negative 1, what is the equation of the tangent line at x is equal to 4? So this is my point of tangency. I need my slope. So that means I need to solve for f prime of 4. This is my derivative equation, so I'm just going to plug in 4. So 4 times 2 minus 4 times 4 plus 3, which is equal to 4 times negative 2 times 7. 4 times negative 2 is negative 8, and negative 8 times 7 is negative 56. So now that I have my point of tangency and my slope, I'm able to write my equation, which would be y minus negative 1, so plus 1, is equal to negative 56 times x minus 4. Then we're going to approximate the value of f of 4.1. This means to use the tangent line since we are approximating. So I'm going to plug in 4.1 into my equation. So y plus 1 is equal to negative 56 times 4.1 minus 4. When we work this out, we get y plus 1 is equal to negative 56 times 0.1. We multiply the negative 56, so y plus 1 is equal to negative 5.6, and finally subtract the 1. So y is equal to negative 6.6. But remember that we cannot leave our answer like this. We have to make sure that we answer the question. So since it was an approximation for f of 4.1, we would write f of 4.1 is approximately negative 6.6. Now we're going to look at our final example. So picture below is the graph of p prime of x. Use the graph to answer the following questions, and then of course we are going to justify. So this is my derivative. Remember that for the derivative, as long as it is above the x-axis, it is positive, and as long as it is below the x-axis, it is negative. So at what values of x does the graph of p of x reach a relative maximum, and when does it reach a relative minimum? Now we have a maximum when the derivative changes from positive to negative. So that means that I would have to see, and even though this is in the way here, this is positive. This is positive. Everything else is negative. So we have a maximum here at x is equal to negative 3, and this is because p prime of x changes from positive to negative. Now our minimum, that occurs at x is equal to positive 3, and this is because p prime of x changes from negative to positive. Oh, I skipped A. A is over here. On what interval is p of x decreasing, and when is it decreasing? So first, let's start with decreasing. P of x is decreasing when my derivative is negative, which is this whole section of the graph. But remember that we have to stop at any critical number because this is when p prime of x is equal to 0, not less than 0. So p of x is decreasing on the interval negative 3 to 0, u 0 to 3, and this is because p prime of x is less than 0. Then our function would be increasing when it's positive. So this would occur on the interval negative infinity to negative 3, u3 to infinity. And this is because p prime of x is greater than 0. Now for our final question, we are going to approximate the value of p of 1.8 using the tangent line approximation if p of 2 is equal to negative 3. So since we're given this point of tangency for when x is equal to 2, 2 is really close to 1.8. So we would have to first write the tangent line, since I don't have it yet, before I can approximate for p of 1.8. So we have our point, so we need p prime of 2, which is on my graph, right, since this is p prime. So when I go to 2, I get that p prime of 2 is equal to negative 5. So now I'm able to write my equation. Y minus negative 3, which is given here, so plus 3, is equal to negative 5 times x minus 2. Now to approximate, I'm going to plug in that 1.8. So y plus 3 is equal to negative 5 times 1.8 minus 2. So y plus 3 is equal to negative 5 times negative 0.2. Negative 5 times negative 0.2 is 1. So then I would have to subtract the 3. So y is equal to negative 2. Now remember, this is my approximation. So that means that p of 1.8 is approximately negative 2. Now, when I look at this graph, and you don't know this yet, but I know that my function at x is equal to 2 is, and I'm just going to give you this information, at x is equal to 2, p of x is concave down. So since it is concave down, even though, remember, this is the graph of the derivative, I cannot determine concavity based on the derivative. This is information that I am just giving to you, that p of x is concave down. So if p of x is concave down, so let's say like this, that means that my tangent line lies above the curve, meaning that this would be an over approximation. I hope that this lesson kind of puts everything together that we've covered so far with derivatives and gave you enough practice. So that's it. Thanks, guys.